Hello everyone, welcome back to Mr. Sanchez. This is the series on dimensional analysis, which is the type of math that scientists and engineers have been using, and people in everyday life. Before I introduced the first base dimensions, mass, length, and time, and I talked about time. So today we're going to be talking about the next base dimension, which is mass. So mass is defined as the amount of matter in an object. How many molecules are in your body right now? That's your mass. So you can say your mass is 100 pounds or 50 kilograms. So the way to think about mass conceptually is on a scale. You've probably stepped on a scale to measure your mass, not your weight, and it tells you how much mass you have, how many molecules are in your body. The reason this is useful is because other dimensions that we'll go over later on will incorporate mass. So people confuse mass and weight all the time because mass is defined as the amount of matter in an object, and weight is how heavy that object is because of gravity. So let's say you have a kilogram ball, the amount of matter won't change in the ball. So that means the ball is 1 kilogram here on Earth, it will be 1 kilogram in space where there's no gravity, and it'll be 1 kilogram on Jupiter where there's a ton of gravity. But the only difference, 1 kilogram ball will feel heavier on Earth than in space, and will feel heavier in Jupiter than on Earth because there's more gravity. So from now on, if you're asking someone how much they weigh, you should really say, what is your mass, if you want to be correct. So here's a trick question that I had on my physics midterm in high school. So let's say you have that kilogram ball. No, let's make it a 1-ton brick. Would it take more energy to move that brick on a frictionless icy surface on Earth, or would it take more energy to move that same 1-ton brick in space? So think about that, and I'll put the answer in a comment a week after I post this video. So as a bit of a recap, we talked about dimensional analysis, specifically with mass, which has units of kilograms or grams in SI units, or pounds or ounces in American units. It's defined as the amount of matter in an object, and it does not change with location. Remember that mass is not the same thing as weight. So if your mass is 130 pounds, your weight is actually dependent on gravity, which we'll talk about later, which means your weight is actually much greater.